Hello, my name is Jeffrey, and this is my video lab report for Physics 2212, lab number 2. Introduction. The purpose of this lab was to analyze electron transfer between two charged pieces of Scotch tape, to present this phenomenon in Python GlowScript, and to apply physics equations to approximate how much charge was transferred between the two tapes. The physics principles used in this lab include Newton's second law, or the momentum principle, the gravitational force on Earth, and Coulomb's law, the equations for which are listed on the left-hand side. I also use a free body diagram to model the top tape as a line charge, or a series of point charges. The main result of this lab was that the electrical force on the top tape was approximately equal in magnitude and opposite in direction to the gravitational force experienced for the net force on the top tape to equal 0. For the physical experiment, the system was the upper tape, and the surroundings were the lower tape, atmosphere, and Earth. The initial conditions were that the tape length was 0.231 meters, the tape width was 0.019 meters, and this lab assumed that both tapes had approximately equal length, width, and charge, no charge was lost during the setup process, and the room was not too humid, as that would affect the charge on the tape as well. The description of the lab. So basically, the upper tape was ripped from the base tape in order to give it a charge. The charge was tested with a hand and several other objects. The upper tape was also loosely hung over a gap and repelled by a similarly charged lower tape, with the displacement being measured. For the observations, the U-tape was electrically attracted to the hand, book, and negatively charged pen, but it was electrically repelled by another U-tape. This led me to conclude that the U-tapes must be positively charged. For the computational model, it was a little bit more advanced compared to Lab 1, as we were actually modeling the tapes as line charges instead of point charges. First, I defined my physical constants, then I defined the mass of the tape and estimated its charge. I also defined a function for the electric field, and then another function to create a line charge. I also created the tapes using some code that's kind of slightly hidden, but you can kind of see it right here. So calculating the electric field and electric force was fairly simple. First, I defined a scale, and then some vectors for the electric force on the top and on the top tape, and the gravitational force on the top tape as well. Then I split the top tape into, in this case, 20 point charges, and then found the electric force from each point charge, summing them up as I went. But for comparison, the magnitude of the charge on the top tape calculated in Lab 1 by setting the magnitude of force equal to the magnitude of the gravitational force yielded that the charge must be 1.4 times 10 to the negative 8 coulombs. For assumptions, approximations, and idealizations, the air resistance was considered negligible since U-tapes were not moving anywhere near terminal velocity. I also assumed each U-tape had the same amount of charge evenly distributed along its length, and this also leads me to my possible sources of error, as these assumptions could have yielded some discrepancy. As you can see on the previous slide, the magnitude of electric force and the gravitational force is not exactly equal. Tapes could have also been discharged from handling, further accumulating to error, and there could have been measurement errors in the real world and rounding errors in GlowScript. In conclusion, if I had modeled each of my tapes as a single point charge like in Lab 1, I'd need to modify the charge in each DQ in the code to be the charge of the whole tape. These estimates would differ because there's likely some discrepancy, again, from the possible sources of error listed on the previous slide, and modeling the tapes as a line charge would be closer to the real value since it more closely imitates the charge distribution on the real-life tapes.